To find the absolute maximum, the first thing you do is find critical numbers, relative maxes and mins. So you have to take the derivative. And then when you find the derivative, you set it equal to 0. And it always helps when you take a derivative of a polynomial like this to pull out GCFs. You set each piece equal to 0, and those are my critical numbers. Alright, now these are possible relative maxes and mins. So we now have to, for absolute max and mins, we have to check these on the original function, not the derivative. And then we also have to check the endpoints of this closed interval. The closed interval, make sure you check the ends and the critical numbers, the relative max and mins possibly. So right here, as you can see, endpoints -5 and 1 and -4 and 0. Put them all kind of in order, and I'm putting it into the original function. When I do all the math, I look at my answer. The one with the largest value is your absolute max. So the largest value is 30. So -430 is my absolute max. Now if I'm looking for an absolute min, well, which is the smallest value? -2. So at 0, -2 will be my absolute minimum value on the closed interval. Again, don't forget to check edges, and don't forget to check in between values that are critical numbers. Now, be careful sometimes too. Sometimes your critical numbers aren't in the interval, so you don't have to check critical numbers unless they're actually in the interval. These are in the interval. Be careful, sometimes they are not in the interval. That's an easy thing to mess up. And also be careful that when you're plugging these values all in, make sure you plug it into the original function, because you want to know what the actual height or output of the function is, not the slope, not the derivative.